Okay, so what is a gradient vector, right? So basically, what I'm gonna say is the gradient vector is going to be the fastest slope. It's the fastest path, right, to go up, like highest, to go up the curve, right? So gradient vector is going to be the steepest way, the steepest path, right? So if I'm like on a level curve, 3D level curve, that's like here, right? I can go anywhere and it'll be the fastest, right? Because it's a circle. But if I'm like, if I'm in the middle of it, right? Like that, right? This is 3D, right? Forget the other dimensions, right? This is going to be the steepest way. So basically, it's going to be the tangent point to both the x and y variable, and that's what gradient descent is. I'm at the gradient vector is. So, um, what I need to show here is that, so why is it the gradient? So like when I draw, so this is a contour of this, so this is z equals x squared plus y squared. Okay, so the vectors field is going to look like that. Okay, you can plug in numbers if you want, but I wouldn't do that. Basically, just, this is a given. Okay, and basically what this means, right? So if I zoom in on this, like this section, basically what I have is that I'm gonna have like, if I'm like it's really really small, right? So I'm like that and that, and the change here is like delta 1. So right, so what contour lines means like is like, okay, so at the z value of 0, right? What's the like shape? Like what's all values that get you that, right? That would be nothing, right? And I have z if it goes 1, right? What are all values that get me that, right? It'll be the circle. And my z value goes 2, I'm gonna have this circle. Z equals 3, I'm gonna have this outer circle, and so on, right? So that's what a contour is. So I take different levels, right? I take like a thin slice, right? And then whatever like lines I have is the contour. So if I have like 0.1, right, and I zoom in here, right? Basically what I need to show you, like, so basically this vector is going to be the closest distance, right? And the closest distance between this line and that line is going to be a straight line. And that's what the gradient vector is. So it'll find the fastest way to change the y value. So I'm at the z value. So gradient vector finds fastest way to change z value, right? So I'm only looking at 2D because 3D is hard, 4D is hard to visualize. So gradient of f finds the fastest way to change z value, right? And the fastest way to change all z values, right, is always going to be perpendicular to, it's always going to be a straight line, and it'll always be perpendicular to the previous contour before it. So that's the conceptual on contour on a gradient, right? So what does that mean on like a surface, right? So how do I draw the gradient vector? So here I just show like the fastest path, right? And okay, so let's look at that. This is the function, right? So the contour is the function, and this is the vector, right? So I have the vector, I have the function, so I'm gonna have f. Okay, that's a vector, and I'm gonna dot it with b, which is gonna be the gradient vector, right? Because um, this is going to be a vector, the contour line, right? Because this is the vector at this point, depending on how it's rotated. And this is also a vector. Okay, actually, okay, forget it. Just like go with it, all right? So this contour, right? I take on a level surface, right? If I take this a level surface, right? I'm gonna get this, and then this is gonna be the vector. Wow, okay, and then I'm gonna have my gradient vector, which points outwards based off this graph. And that's what this is. So I have this and that vector, okay? So I have f, the function, times the gradient, and that's going to be equal to the magnitude of f times the magnitude of f cosine theta. But because this is the right angle, right, because the shortest path is always going to be perpendicular, a straight line, right angle, cosine 90 is going to equal to 0. So this is all going to be 0. So f dot change in f is going to equal to 0. And what does cosine 90 tell you, right? Cosine 90 tells you that the function f is always going to be perpendicular to the gradient vector f. So if I retake this image, right? So this is my function f, right? And the gradient vector is going to be the normal. And that's because f dot gradient f is equal to 0 because cosine is 90. So gradient vector is going to give you the 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 vector of steepest change, and it'll also give you a vector that's perpendicular to the surface. So that's pretty important. That's why when you want to calculate the let me just take a picture. Take the picture of this and the plane tangent to that at that point, right? This is going to be that way. So that's why when you have n, you have, and recall from your formula that for a plane, right, the equation for x, y, z is going to be, and this is vector n, so it's going to be the x component of n times x minus 0, 0, 0, x sub 0 plus ny x minus y0 and c equals z minus 0, 0, and that has to equal to 0. So that's the equation for a plane, and that one you should remember. So important thing, gradient vector is fastest change for the z value, or whatever value it is, and it's going to be always perpendicular to the curve. So let's get right into the, what are we at? Directional derivative. Okay, so basically a directional derivative, right? So um, so we have, so we know that like the fastest way to change, right, is to go along the gradient vector. So what I need to, so what a directional derivative is, let's say we're on the curve. So let me just grab that curve again. I'm on this curve, right? And sheet. Okay, so how would I act if I'm on this curve, right? And what direction would I move, right? So that's basically what it's asking us to solve. So, like, we're normally given the unit vector. We're given a vector, directional vector. So we're given like u, and it's gonna be like cosine. It's gonna be like pi thirds, right? And pi thirds can be represented as a vector, which is gonna be cosine pi thirds, which is root 1/2, and the sine pi thirds was gonna be root 3/2. And basically that's like our direction of x and y. That's our change in x and y. So that's gonna look like x. It's gonna look like something like that. Wait, it's gonna be okay on xy plane. 1, 1, or 3. It's gonna be like that. Okay. So our value is gonna change x and y. So it's gonna go up this circle, right? But the question is like how much does it change? So if I have the unit directional vector, right? If I have the direction of it, right, the change will be the gradient vector, because the gradient vector like determines how you're going to move when you're on this plane, because it's like the steepest change, and it's going to determine like how you move, and that's basically it. So that's why you have gradient of f times u, right, and that's the formula for the directional derivative. And so a recap on what I just said. So the gradient vector is how you're going to change when you're on the surface, right? And normally it gives you like the greatest steepest change, right? But then it's going to multiply by the direction, right? So if you take a point, right, you're going to move, right? You're going to move. But if I take a vector, right, I'm also going to move. But like how much will I move? That's the real question, right? And that's basically what this solves for. Okay. Let me check Paul's notes. I will catch everything. So yeah, it's just the directional times the unit. And yeah, that's basically it. Okay. So what now? Um, lesson plan. So max and min critical points. So okay, so that's not that bad either. I should say that one. Um, okay, let's say I want to redraw. I want to redraw my shape, right? And I have a hump here. Actually, no, this is bad. I have something for this. This looks like a scam. This is like a virus. Guarantee it. Z equals x squared minus. Wait, this is so much easier. Okay. So. Okay. Well, I don't know where I was going with this, but we'll just go with it. Okay, so this is our shape, right? And then basically, like I said, the gradient vector, right? It's going to be the gradient vector is going to be perpendicular to the normal vector. So to the function, to the curve. So when I'm right here, I'll get a different color. So when I'm right here, right, I'm pointing out that way, right? So the max and min. So when you think of a min, right, for a normal curve, right, for a normal like 2D graph, right? So let's say I have like, you know, y equals x squared, right? I have this. That's such a bad example. I can't think of a good example, but let's say I have something like this, right? I don't really have an example, right? So the min's going to occur when the change in that direction is going to be 0, and the change of this, so this is x and y. So this is when the change in y value is going to equal to 0. So that's what the derivative like dy dx, right? So y is changing. So the derivative of y with respect to x means that, like with respect to x, the y value is going to change to 0, like change nothing. And okay, so now I'm going to apply this concept to 2Ds, right? So now dy dx. Now I have, so instead of dy dx, I'm going to have dz dx and dz dy equal to 0. So what this means is that the change is both 0, right? And you can see that's at this point, okay? And so dzy. Okay, so the change is 0, right? And this is going to be the thing. And then if you recall, right, so like, you know how the equation for a tangent, but for a plane, it's going to be n. That should be n. The x component, that's going to be the normal vector of a plane, right? It's going to be of x, and then y, and then z, right? So if I like, oh my god, and y minus y0, blah 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 equals 0, right? But the normal vector is going to equal to 0 vector, right? This is all going to be 0, so then it's just going to be like 0 equals z. See, basically, what's going to happen is, actually it's going to give me points. No, well, yeah, it'll be 0. If there's no vector, it's going to be 0. So all 0 equals 0. So you're just going to get a flat plane. And that's what that tells you. So when there's a max or a min, the directional derivative, the gradient vector is going to be 0 because the perpendicular is going to be a 0 vector, and because you use the perpendicular to make a plane equation, it's going to be equal to 0. Okay, and that's basically how you identify critical points. So for critical points, critical points are going to be all times when the gradient vector of x and y is going to equal to the 0 vector, because it's going to be a plane. That's a flat plane, and hopefully that makes sense. Yeah. Okay. And to classify it, it's a formula. I would just suggest that you just memorize it. So it's an f x x f y y minus the square of x. I do not know it. It's a formula. Yeah, you just do that. Okay. Yeah, pretty easy, and you just kind of memorize that. I guess I could tell you just to show you the intuition for it. So we're gonna do a snippet. And basically the snippets, what's going to happen is, so xx, so the change in x, well, I should probably draw a hyperbolic too. Z equals x. Oh shit, that's hard. Okay. Okay, I'm just gonna capture this. Why not this? Okay. Okay, so what this means, right, is that x is going to be increasing. So wait, I forgot the intuition. Okay, so I don't know, just memorize this. I don't have another video for this. Crap. What happens? This is positive. This also has to be positive. Okay. This is positive. This is negative. This has to be negative. Okay. Okay, I know what's happening. So, when you have like a bowl, like that, right? Basically what happens is that the second derivative, right, is going to be positive and positive. That means at this point, both x and y derivatives, right, both directional derivatives, are going to be increasing. That means it gets steeper. So that means it's going to be a min. And then if they're both negative, that means they're both decreasing. So you can imagine like that, right? The x and y, the x, y part are going to be decreasing because they're negative, because the second derivative is negative. So that's going to be changing negatively, and that's what's happened. And then for a saddle point, oh wait, I have a graph. Okay, for a saddle point, right? For a saddle point, f of x, x is going to equal, and f of y, y is going to be either positive or negative positive, but it doesn't matter. So basically what's happening here is that, so here, the x value is increasing, right? That's what this parabola is. And this is not how you draw them, right? So this is, the x value is going to be increasing, and then y value is going to be decreasing. And that's what the saddle point is, right? Because it's going to be negative minus a negative, and that's going to be a negative. And d equals 0, I have no idea what that means, but, you know, that's that. Okay, that's that. Yeah.